So here we're going to use the rational zero test to find all the real zeros of a polynomial function. So what the rational zero test says is if a polynomial function has a rational zero, which is in the form of a fraction, it would have to be in the form of p over q. P represents all the possible factors of the constant term, the term without the x. So all the factors of 63, 1 and 63. It's not even, so there's no 2. I know 3 goes into it, and that's 21 times. 4 does not. Oops. 4 does not. 5 obviously does not. 6 doesn't. 7 does. 7 and 9. 8 does not. 9, well, we're all up to 9, so that's it. 1, 3, 7, 9, 21, 63. Q is all the factors of the leading term, the leading coefficient, which is 2. So we lucked out there. That's just 1 and 2. Now, all zeros have to occur in the form of P over Q. So any combination of all these numbers, like this, if I use P as 1, we have 1 over 1 and 1 over 2. So 1 over 1, 1 over 2. Now I'm going to go to P equals 3. 3 over 1, 3 over 2. So I'm just combining all these possible combinations. 7 over 1, 7 over 2. 9 over 1, 9 over 2. And so on. So I'm just going to reduce. And by the way, these factors can be plus or minus because 63, its factors could be negative 1 and negative 63. So I know all of them will be plus or minus. So I have 1, 1 half, 3, 3 halves, 7, 7 halves, 9, 9 halves, and so on. So now I have to test. So here's the problem. This possibly does not have any rational zeros, so none of these may not work. So it's just like brute force here. We're going to have to test it with synthetic division. If they work, if it's a 0, you'd have to get a remainder of 0. It's just like plugging 1 into this. If you plug in 1, uh, f of 1 would be 0 if you get a remainder of 0. So we're looking for zeros, so we need to get a remainder of 0. As soon as you see it not working, stop and go to the next one. This is not going to be, that's going to be negative 2. It's not going to equal 63, so I'm done with that. Let's try 3. And I could try negative 1. Well, let's do it. Let's try negative 1. Negative 2, negative 19, negative 19. This is not going to be 63 here, so I'm done with 1s. So only go as far as you need to. I'm going to skip the 1 half. That's just too much. I mean, possibly 1 half is the only thing that works, but I'm going to try the easier ones first. Now, 3 definitely has a better chance than 1, you can see, because 63 is this. This has to get relatively large to work, and 1 would not do that. So 3 times 2 is 6, negative 11. It's negative 33. It's negative 21, I think. Yes. Well, this is looking good. 3 times negative 21 is negative 63. We found one. So that's good because we started with a cubic, a third degree. That means this would be a quadratic. So I can deal with quadratics. I don't have to keep testing and getting zeros because I found that x equals 3 is a 0, But the other zeros will come from this quadratic function down here, which is 2x squared minus 11x minus 21. So I'm done with synthetic division. I'd rather factor this or use the quadratic formula. So if it doesn't factor, you have to use the quadratic formula. But factoring is easier, so let's see if it factors first. It factors if there's factors of negative 21 times 2, negative 42, that add up to negative 11. So we have 2 and 21, we have 3 and 14, that looks good. So 3 times a negative 14 is 42, and those factors add up to a negative 11. So we're good. This does factor 2x squared plus 3x minus 14x minus 21. Factor out an x from the first two factors. Factor out a negative 7 from the next two factors. So we have 2x plus 3, after we factor that out, times x minus 7 equals 0. So our other two zeros are x equals negative 3 halves and x equals 7. So our three zeros are x equals 3, x equals 7, and x equals negative 3 halves. So this will be easy to graph as well, as you already know. Also, it's not surprising that we got three zeros and the degree is 3. Now, that doesn't always have to happen. We'll talk about that more at a later date, but often it does. You can never have more zeros than the degree. So if we had 4 zeros, you know something is very wrong. So that's how you use the rational zero test.